So, we are going to learn about this MPU6050 sensor, which is a 3-axis accelerometer along with the 3-axis gyroscope. This sensor is basically an IMU, which is initial measurement unit. Now, let us get familiar about what does it do actually. So, if you are able to see this, there is this a small chip. If you are able to see this chip, in this chip we have all the uh, sensors embedded onto it. Okay, the first one is accelerometer, which measures linear acceleration. So, let us take an example of this 3-axis. Okay, let us call it x, y, z. Now, whenever there is a motion, it will calculate the acceleration related to each axis. So, now when we say accelerometer, there are two things. One is so there are two things here. One is 3-axis accelerometer, which this 3-axis accelerometer will give you linear acceleration along all the 3 dimensions, that is x, y and z. This 3-axis gyro will help you to recognize angular velocity. So, with the combination of these both, we are able to detect the angle and position of the gyroscope. So, as you can see here, so here as you can see, these all pins are not going to be utilized, only few of them are going to be utilized. So, the first 2 pins are the first one is the power pin, which is nothing but VCC. You have to supply a voltage between 3 volts to 5 volts, which you need not do, we have already connected it. So, there is a ground which has to be connected, and there are serial clock and serial data. Both of them are being utilized to communicate through I2C protocol. So, there are auxiliary serial data and auxiliary serial clock, in which we will utilize this in case we have another device on the same I2C channel, and there is an interrupt. So, we are going to cover about inter-integrated circuit, which is I2C communication. This is another form of serial communication to send information from one device to another device. Let us take an example here. I have a microprocessor which can be ESP32 or any Arduino based board. Now, I need to interface it with the MPU6050. Now, there should be some physical connection between ESP32 and MPU6050, only then the communication is possible. So, what is that communication is? You need to have a physical connection of SDA, which is your serial data, and SCL, which is serial clock. So, this is a form of I2C communication. Now, this I2C communication is similar to your you can imagine it as a router. Okay, imagine this is the server. Okay, now there will be if I want to interface some another device on the same I2C communication channel, then how do I do it? I have to again uh, connect some other device which is MPU6050. Okay, how do I connect another MPU6050? Now the answer is simple. You have to just connect the SDA. So, you have to connect SDA and SCL pins to communicate. Now, how do I differentiate between two MPU6050 is this is going to have some address in hexadecimal form like this 0x68, which is the first device on the I2C bus. So, another device may be having some other address which is 69. So, in this case we are going to utilize the same I2C channel for both the MPU 6050. Imagine this 6050 is one client, this is another client. So, C1 and C2. Now, what happens is both of them are connected to the same SDA SCL pins. The differentiation happens with this address which is helping us to identify a particular device. So, this is where the difference is. Whenever you want to connect to this MPU 6050, you have to use a library called wire. So, wire is the library used to initialize this I2C bus communication. There you need to mention the address of this MPU 6050 and then you can start reading the values from the device. So, when I say MPU 6050, it is a sensor which has a inbuilt IMU, which is inertial measurement unit. Inertial measurement unit is nothing but it is a combination of 3-axis accelerometer and gyroscope. Again I will specify this one. Accelerometer will give you linear acceleration values, whereas your gyroscope will give you angular velocity. So, this is how this I2C communication protocol will work. So, calibrating the MPU 6050 sensor, first of all we have to understand what is the need of this calibration of MPU 6050. Basically, whenever you are going to use the device for the first time, you have to calibrate it. The purpose of this calibration is to remove the zero error and as well as to improve precision and accuracy of the values of the accelerometer and gyroscope. Now, whenever you are purchasing this device, you have to calibrate. We will show you how to do the calibration part now. So, this is a basic code that you need to upload onto your ESP32 or whatever device you are calibrating the MPU 6050 with. So, as you can see here, this is not the only code which will help you to calibrate. This is one of the code. So, in this code what we are going to do is we are going to take the average of few hundreds of values of individual axes of the accelerometer and the gyroscope. So, we will get started from the beginning. So, we have included the I2C library here. Can we increase the font? So, this I2C dev.h is a library that we need to include. There is MPU6050 that we have already done installation in as part of the setup, and there is a wire.h library. Remember, I mentioned this wire.h library will initiate the I2C bus, and we shall be able to communicate on that bus. So, here there are three variables defined here. The first one is the buffer size. So, this is nothing but the number of values that you are going to collect, a few hundreds or thousand readings of the individual axes. Okay, here we have given it as 1000. So, it what it does is it will take 1000 values and it will calculate the what do you call it, the average of the all the readings. Let us take an example of x axis, y axis and z axis. So, in the accelerometer for the x axis we will be having a buffer of 1000 values, of which will calculate the average. Now, there is another value which is axle dead zone. This is a value where the accelerometer is going beyond a number, then it is an error. So, 8 is defined, we can manipulate this according to our own needs, and so that we get good calibration. So, as mentioned here, the accelerometer error allowed. So, our dead zone is defined as 8. To get a more precision value, you have to increase or you have to decrease the number here. It is a quite big number, 8. So, remember, whenever you increase the buffer size, the program will take more time to calculate those values. So, here we have given 1000 values. So, it will be done within a few seconds. So, we have defined AX. First of all, we have created this MPU6050, we have initialized. We have few values like AX, which AX, AY and AZ, which represents so AX, AY and AZ is nothing but your accelerometer values, and GX, GY and GZ is gyroscope values. Okay. So, now in this code we have defined some mean AX, mean AY and mean AZ, and we have instantiated a variable called state. So, first of all we will see the setup function, and we have defined some offsets for gyro and accelerometer as well. Please scroll down. So, as you can see here, this is our setup function. So, remember, you have to always initialize this wire library using wire.begin, so that you start communicating with the device. So, remember, in our in the last session we have seen that there is individual address assigned to individual I2C devices. Okay. So, what is this I2C device? Actually, in our case it is a MPU6050 sensor which has some address which is by default 0x68, which is a hexadecimal address. So, it represents the I2C device. Okay. So, here a wire library will automatically detect the I2C devices. After we have defined this, then we have to initialize the accelerometer by using initialize method. Now, as you can see here, scroll down a bit. So, I am trying to explain this program now. Here what is happening is we have stopped the function here, the setup function here, unless there is a character has been sent on the serial dot available. I mean on the serial monitor, whenever you want to press any key or something, only then the other code will get executed. So, here there is a infinite loop here which stops the code from execution. So, we will show you how to begin with. Just show the camera. So, just plug the device. Did you plug the device? So, we have it is not powered on.
It is.
So, as you can see, we have plugged in the device, and now we are going to upload this code. Remember, this is the configuration that you have to select. The board is Zio ESP32S3, and port number is depending upon the available COM port. So, we are going to upload this code. So, please show the camera also. So, the execution will start only when you send something on the serial monitor, which is nothing but at the top right corner on your Arduino IDE there will be a serial monitor. Just show the serial monitor. So, it is like how you read values using um, uh, input method in Python. You may have used input method several times, where you create a variable input equals to input which with uh, curly braces. So, as you can see here, so the code has been uploaded. Now, whenever you enter something on this serial monitor, which is an input, it will take as input, and the remaining of the code will get executed. Now, I will tell you how to do this process. Okay, just show the camera. So, as you are seeing here, we have kept our device on a flat surface facing the camera. You should face the camera on the flat surface, so that you have to put the camera down, so that this is on a flat surface. You are able to calculate the accelerometer and gyroscope. This is where you will get the zero values, all zero values. To, so, like this you have to put this device on a flat surface by facing the camera on the flat surface. Okay, the camera should not be pointing upwards, it should be downwards. Now, once we enter something, it can be any text. So, as you can see here, the MPU6050 calibration sketch has been started. The connection was successful. So, reading the sensor values for the first time, and it is calculating the offsets. So, it will take some time to calculate the offsets. So, we are able to figure out some values which are nothing but our offsets. So, the format of this data is the first three values are representing the accelerometer values along x, y and z directions, and the next three values are representing gyroscope values which are x, y, z again. So these are the offsets which are figured out for that device. Now these values have to be copied and used as the offsets. So I think we'll go through the code now, what exactly it did. So scroll down. So remember to keep the device on a flat surface so that you calculate the offset properly, and the device should not be moving around. It should be stationary and it should not move. So initially once you start the calibration part, initially we will set all the offsets to 0 so that we decide that whatever position the device is in is the origin. So all the values are going to 0. Now go to the loop function here. So in the beginning the first step is you have to calculate the average of individual what do you call readings. Okay, average of a few hundred values of readings for individual axes of the accelerometer, which is our mean of the sensors. Just go to this function. So here, as you can see here, we are going to read accelerometer and gyroscope values. We are going to buffer all the values in buffer variables, buffer AX, buffer AY and buffer AZ. Similarly for gyroscope also we have buffer variables. So how do you read those values is axle gyro, which is our MPU6050 variable, and there is a function get motion 6 which will give you values of individual axes for accelerometer and gyro. So in the first step the initial 100 measures are discarded so that we get a good precision and accuracy. Scroll down. So this is how we are calculating the mean of accelerometer gyroscope values. So it is a pretty easy code that you can understand. So again there is another method that is followed after this thing. Here what we are doing is we are defining our new offset, which is nothing but 0 minus this whatever mean that you have calculated, the average of individual axes, and we are going to again do the set the acceleration offsets and gyro offsets. Scroll down. So here there are some in case there is a failure or some error, then we'll verify here by checking the dead zone values for accelerometer and gyro dead zones. Scroll down. So as you can see here, just open the serial monitor. So, here we have got our offsets which you have to use throughout your IMU program. You have to set these values, you should keep these values as the offset. Okay. I mean, that is all. No? So, can we show them a program where we set the offsets? This is for data forwarding. Okay, wait. So, here there is another program where we are going to send values through a data forwarder, which is our edge impulse data forwarder. This is a program for that. So, in the setup method, what you have to do is, whenever you have initialized the IMU, you have to set the offsets, saying that this is the orientation, this is the basic orientation that you will have, which is a starting point for us. So, you may be having question, why do we need orientation? So, let us say I will give you a small example. We are going to create and identify two kind of gestures. So, let us say I write a variable L. So, like this. So, this is a small L. Okay. Now, what is the orientation of our device matters here. Let us say I kept it in reverse here. So, I do the same L gesture. Okay. What will happen now? It will recognize it as R gesture, which is this. Okay. So, it is really important that you know the orientation of the device, otherwise your gesture is going to be inaccurate and it will be, there will be some errors. So, this is where you have to set the offset values. Whatever we have got, we are going to change it. Please change it. So, just remember that we have to set these offsets whenever you are using IMU programs. So, x axial offset does not change, or okay, we are going to explain you this code again. So, this specific code will help you to print our accelerometer and gyroscope values on the serial monitor. Okay. So, first of all, the first part is to include the I2C dev header. The second part is MPU6050, and the third one is for initializing the I2C bus, which is wire library. So, here what we have done is we have defined few variables here, which is, so this is another program that we are going to discuss, which will give us accelerometer and gyroscope values printed on the serial monitor. The first thing in this one is we have to include some libraries, which are I2C dev.h, MPU6050 and wire.h, which is a I2C bus library, which will help us to connect to I2C device. There are again three variables here, which are frequency, hertz, interval in which we have to, so interval in milliseconds. Okay, that we are going to define it. There is axial range that we are defined. There is a method. So, please scroll down, go to the setup. So, as usual, we have MPU6050 initialized here along with accelerometer. So, always in the setup you have to always initialize the wire library, so that we begin the communication to the I2C device. Next we have to initialize the IMU using the initialize method. Now there is some delay added here so that the device get prepared. After that we have to use the offsets that have been calculated by the calibration program that we have uploaded earlier, and these are the values that you need to set. So please do not use these values as the offsets, because it is specific to a device. Okay, you should not be using these values as this in your device, because you have to calculate the values on the device. Okay, just scroll down. So as you can see here, uh, we have in the loop we are going to print this accelerometer values based on the some interval which is defined as 1 second, which is 1000 milliseconds. So for every 1000 milliseconds we are going to get the acceleration values, and we are going to convert it to meter per second square here, and this is nothing but it will print the values on the serial monitor. So we will just go through this, upload this code and see what is happening. So every 1 second we are going to print accelerometer values which are given by the MPU6050. So as you can see, the code has been uploaded. So if you are able to see, there are some values which are not equal to 0, but almost in stable position we are able to get these values. So the z axis is 9.6 here. So just we are going to show you how the values are getting changed when we move the device. So as you can see here, the values are varying whenever there is a movement of the device. So we can say that our IMU is working for all the 3 axes properly. So we will also show you the serial plotter. So remember, based on these values only you are going to build your gesture recognition program and develop the model. So as you can see here, you can see this graph. Okay. So whenever I move that device, there is a lot of change in the graph. So we are going to continue with the gesture recognition on edge impulse in the next session.